So we're looking real quick at our foldable that we made yesterday, right? We had three forms that we talked about: standard form, vertex form, and intercept form. And the forms are right here for you to see. Okay? Each piece of information about that particular form is on each line. Okay? Negative b over 2a, you get the b and the a by looking at the standard form, right? Where is a always? In front of x squared, right? It's the multiplier for x squared. It's the coefficient for x squared, right? Where's b always? In front of the x. It's the coefficient of the x. Does it include the x? No, not at all, right? And where is c always? At the end. So what if there's not a c? What's c? Zero. What if there's not a b? What's b? Zero. Is there ever going to be not an a? Well, it might look like that, right? It might just be x squared, and if that's true, a is 1, correct? But is there ever going to be not an x squared? No, because then it's not a quadratic, right? Okay? Looking at vertex form, where's the h? Inside the parentheses, right? Where's the k? Outside the parentheses. And if one of them are not there, it's 0, right? Okay? Remember, this vertex form is where we have to be careful of the signs, because it's x minus h, right? X minus h. So minus is part of the formula. And then on the intercept form, we also have to be careful of the signs here, because it's x minus p and x minus q, so we have to be careful of that. But again, we talked about all this yesterday. I'm just going back over it real quick for you, right? Okay? So I want to do some very specific examples about each one of these. Characteristics of quadratics, just like we talked about yesterday. We're just going into a little bit more detail. Okay? So, can you tell me what form this is in? That's definitely standard form, right? First of all, there's no parentheses at all, so that kind of leaves both of those out, right? So standard form is what's left. So let's identify things that we know. What is this right here? What's the 2? That's a. What is the 8? And what about the negative 9? C. So for my axis of symmetry in standard form, I have, let me close these up real quick. I have negative b over 2a, right? So how do I find negative b? Yeah, I just look, right? What's b? B is 8, so what's negative b? Negative 8 divided by 2 times a. And in this problem, a is 2. So what is negative 8 divided by 4? Negative 2. So the first thing I know is my axis of symmetry. But remember, how do we write our axis of symmetry? X equals, absolutely. X equals negative 2. But see, what I also just found was what? The x coordinate of my vertex, right? So my vertex is a point. I have negative 2, comma, something. How do I find that something again? I take my x and substitute it in, right? Okay, so 2 times negative 2 squared plus 8 times negative 2 and then minus 9. Okay, so what's negative 2 squared? What's negative 2 times negative 2? Positive 4. What's positive 4 times 2? 8. What's 8 times negative 2? Negative 16, and then minus 9. So what's 8 minus 16? Negative 8 minus 9? Negative 17, right? So where's my vertex? Negative 2, negative 17. How do I find my y-intercept if it's in standard form? Yeah, you look with your eyes, right? Look at C. What's C in this problem? But it's the x. It's the y-intercept. So what's x? 0. So 0, negative 9. Done. Any questions about that? Okay. Look at this next example. What form is it in? Okay, that's really close. Vortex has something to do with the tornado, right? Okay, so what's this one called? Vertex form, okay? Not that I mind talking about tornadoes, just maybe not right this second. We can do it later, okay? So how do I find my axis of symmetry? Well, before we do that, shouldn't we identify what we know? Okay, so vertex form says A, well, that's A, right? The multiplier in front of the parentheses, that's A. And if nothing was there, what would A be? See, oh, it would be 0? Oh, it would be 1, right? Because if it was 0, it would be 0. Yes?
Do you have Kirsten?
Yes, I do.
You send her to the office, please. She's leaving.
Yes, I will.
Thank you.
If this was 0, 0 multiplied by this would all be gone, right? So would that even be a quadratic anymore? No, so if it's not there this time, it is 1. Sometimes if it's not there, it's a 0, right? Okay, but this time if it's not here, it's a 1. Okay, but in this problem, A is 3. And what's this one right here? That's H. Notice that I did not underline the negative. Notice I just underlined the 4. Is that a big deal?
Yes.
Because the minus is part of the formula, right? And then what's K? 2. Did I underline the sign this time? Yes. Okay. So for the axis of symmetry, x equals h. So I just look with my eyes, x equals 4. But remember, if I know the axis of symmetry, I also know the x coordinate of the vortex, yes. You are correct. It is vertex, and that's okay. Okay. How do I find the y coordinate? Oh yeah, look, right? It's k, isn't it? Okay. So 4 comma what? 2. It's right there. Now how do I find the y-intercept? Because it doesn't say that anywhere here, does it? No. Well, you can if you want, but that's not really the y-intercept, is it? What's true about every y-intercept?
It's always the last. Or it's always 0 for x.
X is always 0, isn't it? So what if I put 0 in for x? What is 0 minus 4?
Negative 4.
What is negative 4 squared?
Positive 16.
Positive 16. What is 16 times 3? 48 plus 2. So what's my y-intercept? 0, comma 50. Now, did we talk about that yesterday? Not for this one, right? We talked about it for this, and we talked about that x is always 0 for the y-intercept. So we took some prior knowledge and did something new. Was it difficult? No. We figured it out, right? Good. Give yourself some credit for that. Not everybody can do that. Okay? All right, last one. What form is it? Intercept form. So we're using this last tab right here. What do you think we ought to identify first here? What you know, right? So what do I know? What's this? A. What's this? P. And what's this? Q. That's kind of sneaky though, isn't it? Because what's the value of P? Just 5. What's the value of Q? Negative 1, isn't it? Because it's x minus Q, isn't it? So we just have to be careful of that when it comes time to talk about Q, right? Okay. So to find the axis of symmetry, we say P plus Q. So P is what? 5 plus Q is what? Negative 1 divided by 2.
2.
What's 5 plus negative 1?
4.
And 4 divided by 2?
2.
So what's the axis of symmetry?
2.
Dang it! I knew you were going to say that. What's the axis of symmetry?
X equals 2.
X equals 2. You know the difference though, right? 2 is just a number. X equals 2 is the equation of a line, which is what I need for my axis of symmetry, right? So if I know the axis of symmetry, what else do I know? Part of the vertex, right? The x coordinate of the vertex. How do I find the y coordinate?
You look.
Not this time. This time I have to plug it in, right? Okay. So let's see, -2. What is 2 minus 5? -3. And what's 2 plus 1? 3. So what is -2 times -3? Positive 6 times 3? 18. How do I find a y-intercept?
It's right there. It's
What's true about every y-intercept? X is 0. So what if I let x equal 0? What's 0 minus 5?
-5.
And what's 0 plus 1?
1.
1, right? So -2 times -5? 10 times 1? 10. Now there's one extra thing here on this one. Why? Because in intercept form, aren't these the two things that we're kind of focused on? The x-intercepts? So what are the x-intercepts? P 0. What did we decide P was? 5. So 5, 0, and -1, 0. Very good. Okay. Guys, if it's true that all y-intercepts have x as 0, is the opposite true for x-intercepts? The y's are 0? Yeah. Okay. Now there's one more thing I want to show you. Okay. One more thing I want to show you. You know that if there's ever a time that you can use your calculator, I'm going to show you, right? When am I going to show you? After I show you the math, right? I don't mind you using the calculator to help as long as you understand the math that's going on behind it. So the one that we just did, is that right if we just do the one we just did? So in my calculator, I need a graph. Okay, I need a graph page, and I'm going to put in -2, x minus 5, and x plus 1. Okay, so first of all, did I expect it to open down? Why? Because A is negative, right? If A is negative, I know it's going to open down. Did I expect the vertex to be somewhere I can't see? Because I said it was 218, right? Mine only goes up to 6, or almost 7, right? But if I know the x-coordinate of the vertex, which I find pretty quickly here, right? Watch what I can do. Menu, analyze, which is number 6. And then what if I chose maximum? Why would I choose maximum? Why wouldn't I choose vertex? Is vertex on the list?
No.
No, so I have to know if it's a minimum or maximum, right? So why did I choose maximum again? Because it opens down. So if I choose maximum, which is number 3, there's this dotted line that appears. And it wants the lower bound. So I want to move it to where I know it's on the left side of the vertex and click that middle button right there. And then I want to move it to where I know it's on the right side of the vertex. Even though I can't see it, do you agree with me that my vertex would be in that shaded area? Because remember what we talked about yesterday is that my vertex is in between my two intercepts. So I just need to make sure that that's in between, right? And then it readjusts the window for me and tells me where my vertex is.
Isn't there a way to do that with like where x crosses
The intercepts? Those are called zeros. And so if we look at menu, analyze, we could choose 0, that very first one. Okay? So could I have done that on both of these other examples to find the vertex?
Yes.
I could have. Do you think it would take longer or shorter? Well, it depends, right? It really depends. Is it going to be faster or shorter on intercept form? Or faster or longer on intercept form? It's going to be way longer, right? Because intercept form, what do I have to do to find the vertex? Look, right? But on a standard form or intercept form, it might be quicker to use your calculator. When am I okay with you using your calculator? When you know the math. Okay, when you know the math. You know that, correct? I'm never going to hide what the calculator can do. I'm just not going to show you until I think you're ready for it. Is that fair? Okay, do you have any questions about any of these characteristics of quadratics that we talked about today? Are any of them new from what we talked about yesterday? So why did we do them again? Remind you, refresher, and because I really think they're important and I need you to know how to do them. Okay? Exactly. Okay. Plus, I did show you the calculator today, right? Okay. Any questions before you get started?